Computer system and overview. Introduction. A computer along with additional hardware and software together is called a computer system. A computer system primarily comprises a central processing unit, CPU, memory, input-output devices and storage devices. All these components function together as a single unit to deliver the desired output. Definition of computer: a computer is an electronic device that can perform a variety of operations according to a set of instruction called program. Computer programming language. Computer programming language, any of various languages for expressing a set of detailed instructions for a digital computer. Such instructions can be executed directly when they are in the computer manufacturer's specific numerical form known as machine language, after a simple substitution process when expressed in a corresponding assembly language, or after translation from some higher-level language. Although there are many computer languages, relatively few are widely used. Machine and assembly languages are low-level, requiring a programmer to manage explicitly all of a computer's idiosyncratic features of data storage and operation. In contrast, high-level languages shield a programmer from worrying about such considerations and provide a notation that is more easily written and read by programmers. Language types. Machine and assembly languages. A machine language consists of the numeric codes for the operations that a particular computer can execute directly. The codes for strings of zeros and ones, or binary digits, bits, which are frequently converted both from and to hexadecimal, base 16, for human viewing and modification. Machine language instructions typically use some bits to represent operations, such as addition, and some to represent operands, or perhaps the location of the next instruction. Machine language is difficult to read and write, since it does not resemble conventional mathematical notation or human language, and its codes vary from computer to computer. Assembly language is one level above machine language. It uses short mnemonic codes for instructions and allows the programmer to introduce names for blocks of memory that hold data. One might thus write addPay total instead of 01101010100101000 for an instruction that adds two numbers. Assembly language is designed to be easily translated into machine language. Although blocks of data may be referred to by name instead of by their machine addresses, assembly language does not provide more sophisticated means of organizing complex information. Like machine language, assembly language requires detailed knowledge of internal computer architecture. It is useful when such details are important, as in programming a computer to interact with peripheral devices, printers, scanners, storage devices, and so forth. Algorithmic languages. Algorithmic languages are designed to express mathematical or symbolic computations. They can express algebraic operations in notation similar to mathematics and allow the use of subprograms that package commonly used operations for reuse. They were the first high-level languages. Fortran. The first important algorithmic language was Fortran, formula translation, designed in 1957 by an IBM team led by John Backus. It was intended for scientific computations with real numbers and collections of them organized as one- or multidimensional arrays. Its control structures included conditional if statements, repetitive loops, so-called do loops, and a goto statement that allowed non-sequential execution of program code. Fortran made it convenient to have subprograms for common mathematical operations, and built libraries of them. Fortran was also designed to translate into efficient machine language. It was immediately successful and continues to evolve. ALGOL. ALGOL, algorithmic language, was designed by a committee of American and European computer scientists during 1958–60 for publishing algorithms, as well as for doing computations. Like Lisp, described in the next section, ALGOL had recursive subprograms, procedures that could invoke themselves to solve a problem by reducing it to a smaller problem of the same kind. ALGOL introduced block structure, in which a program is composed of blocks that might contain both data and instructions and have the same structure as an entire program. Block structure became a powerful tool for building large programs out of small components. ALGOL contributed a notation for describing the structure of a programming language, Bacchus in our form, which in some variation became the standard tool for stating the syntax, grammar, of programming languages. ALGOL was widely used in Europe, and for many years it remained the language in which computer algorithms were published. Many important languages, such as Pascal and Ada, both described later, are its descendants. C. The C programming language was developed in 1972 by Dennis Ritchie and Brian Kernighan at the AT&T Corporation for programming computer operating systems. Its capacity to structure data and programs through the composition of smaller units is comparable to that of ALGOL. It uses a compact notation and provides the programmer with the ability to operate with the addresses of data as well as with their values. This ability is important in systems programming, and C shares with assembly language the power to exploit all the features of a computer's internal architecture. C, along with its descendant C++, remains one of the most common languages. Business-oriented languages. COBOL. COBOL, Common Business-Oriented Language, has been heavily used by businesses since its inception in 1959. A committee of computer manufacturers and users and U.S. government organizations established CODASYL, Committee on Data Systems and Languages, to develop and oversee the language standard in order to ensure its portability across diverse systems. COBOL uses an English-like notation, novel, when introduced. Business computations organize and manipulate large quantities of data, and COBOL introduced the record data structure for such tasks. A record clusters heterogeneous data, such as a name, an ID number, an age, and an address, into a single unit. This contrasts with scientific languages, in which homogeneous arrays of numbers are common. Records are an important example of chunking data into a single object, and they appear in nearly all modern languages. SQL. SQL, Structured Query Language, is a language for specifying the organization of databases, collections of records. Databases organized with SQL are called relational, because SQL provides the ability to query a database for information that falls in a given relation. For example, a query might be find all records with both last name Smith and city New York. Commercial database programs commonly use in SQL-like language for their queries. Education-oriented languages. Basic. Basic, beginner's all-purpose symbolic instruction code, was designed at Dartmouth College in the mid-1960s by John Kemeny and Thomas Kurtz. It was intended to be easy to learn by novices, particularly non-computer science majors, and to run well on a time-sharing computer with many users. It had simple data structures and notation, and it was interpreted. A basic program was translated line by line and executed as it was translated, which made it easy to locate programming errors. Its small size and simplicity also made BASIC a popular language for early personal computers. Its recent forms have adopted many of the data and control structures of other contemporary languages, which makes it more powerful but less convenient for beginners. Pascal. About 1970, Nicholas Wirth of Switzerland designed Pascal to teach structured programming, which emphasized the orderly use of conditional and loop control structures without goto statements. Although Pascal resembled ALGOL in notation, it provided the ability to define data types with which to organize complex information, a feature beyond the capabilities of ALGOL as well as Fortran and COBOL. User-defined data types allowed the programmer to introduce names for complex data, which the language translator could then check for correct usage before running a program. During the late 1970s and 80s, Pascal was one of the most widely used languages for programming instruction. It was available on nearly all computers, and, because of its familiarity, clarity, and security, it was used for production software as well as for education. Logo. Logo originated in the late 1960s as a simplified Lisp dialect for education. Seymour Papert and others used it at MIT to teach mathematical thinking to schoolchildren. It had a more conventional syntax than Lisp and featured turtle graphics, a simple method for generating computer graphics. The name came from an early project to program a turtle-like robot. Turtle graphics used body-centered instructions, in which an object was moved around a screen by commands, such as left 90 and forward, that specified actions relative to the current position and orientation of the object rather than in terms of a fixed framework. Together with recursive routines, this technique made it easy to program intricate and attractive patterns. HyperTalk. HyperTalk was designed as programming for the rest of us by Bill Atkinson for Apple's Macintosh. Using a simple English-like syntax, HyperTalk enabled anyone to combine text, graphics, and audio quickly into linked stacks that could be navigated by clicking with a mouse on standard buttons supplied by the program. HyperTalk was particularly popular among educators in the 1980s and early 90s for classroom multimedia presentations. Although HyperTalk had many features of object-oriented languages described in the next section, Apple did not develop it for other computer platforms and let it languish. As Apple's market share declined in the 1990s, a new cross-platform way of displaying multimedia left HyperTalk all but obsolete. See the section World Wide Web Display Languages. Object-oriented languages. Object-oriented languages help to manage complexity in large programs. Objects package data and the operations on them so that only the operations are publicly accessible and internal details of the data structures are hidden. This information hiding made large-scale programming easier by allowing a programmer to think about each part of the program in isolation. In addition, objects may be derived from more general ones, inheriting their capabilities. Such an object hierarchy made it possible to define specialized objects without repeating all that is in the more general ones. Object-oriented programming began with the Similar Language, 1967, which added information hiding to ALGOL. Another influential object-oriented language was Smalltalk, 1980, in which a program was a set of objects that interacted by sending messages to one another. C++. The C++ language, developed by Bjorn Stroustrup at AT&T in the mid-1980s, extended C by adding objects to it while preserving the efficiency of C programs. It has been one of the most important languages for both education and industrial programming. Large parts of many operating systems were written in C++. C++, along with Java, has become popular for developing commercial software packages that incorporate multiple interrelated applications. C++ is considered one of the fastest languages and is very close to low-level languages, thus allowing complete control over memory allocation and management. This very feature and its many other capabilities also make it one of the most difficult languages to learn and handle on a large scale. C#. C#, pronounced C# like the musical note, was developed by Anders Heilsberg at Microsoft in 2000. C# has a syntax similar to that of C and C++ and is often used for developing games and applications for the Microsoft Windows operating system. Ada. Ada was named for Augusta Ada King, Countess of Lovelace, who was an assistant to the 19th-century English inventor Charles Babbage, and is sometimes called the first computer programmer. Ada, the language, was developed in the early 1980s for the U.S. Department of Defense for large-scale programming. It combined Pascal-like notation with the ability to package operations and data into independent modules. Its first form, Ada 83, was not fully object-oriented, but the subsequent Ada 95 provided objects and the ability to construct hierarchies of them. While no longer mandated for use in work for the Department of Defense, Ada remains an effective language for engineering large programs. Java. In the early 1990s, Java was designed by Sun Microsystems Incorporated as a programming language for the World Wide Web, WWW. Although it resembled C++ in appearance, it was object-oriented. In particular, Java dispensed with lower-level features, including the ability to manipulate data addresses, a capability that is neither desirable nor useful in programs for distributed systems. In order to be portable, Java programs are translated by a Java virtual machine specific to each computer platform, which then executes the Java program. In addition to adding interactive capabilities to the Internet through web applets, Java has been widely used for programming small and portable devices, such as mobile telephones. Visual Basic. Visual Basic was developed by Microsoft to extend the capabilities of BASIC by adding objects and event-driven programming, buttons, menus, and other elements of graphical user interfaces, GUIs. Visual Basic can also be used within other Microsoft software to program small routines. Visual Basic was succeeded in 2002 by Visual Basic.NET, a vastly different language based on C#, a language with similarities to C++. Python. The open-source language Python was developed by Dutch programmer Guido van Rossum in 1991. It was designed as an easy-to-use language, with features such as using indentation instead of brackets to group statements. Python is also a very compact language, designed so that complex jobs can be executed with only a few statements. In the 2010s, Python became one of the most popular programming languages, along with Java and JavaScript. Declarative languages. Declarative languages, also called non-procedural or very high-level, are programming languages in which, ideally, a program specifies what is to be done rather than how to do it. In such languages there is less difference between the specification of a program and its implementation than in the procedural languages described so far. The two common kinds of declarative languages are logic and functional languages. Logic programming languages, of which Prolog, programming and logic, is the best known, state a program as a set of logical relations. Example, a grandparent is the parent of someone. Such languages are similar to the SQL database language. A program is executed by an inference engine that answers a query by searching these relations systematically to make inferences that will answer a query. Prolog has been used extensively in natural language processing and other AI programs. Functional languages have a mathematical style. A functional program is constructed by applying functions to arguments. Functional languages such as Lisp, ML, and Haskell are used as research tools in language development, in automated mathematical theorem provers, and in some commercial projects. Scripting languages. Scripting languages are sometimes called little languages. They are intended to solve relatively small programming problems that do not require the overhead of data declarations and other features needed to make large programs manageable. Scripting languages are used for writing operating system utilities, for special-purpose file manipulation programs, and, because they are easy to learn, sometimes for considerably larger programs. Perl was developed in the late 1980s, originally for use with the Unix operating system. It was intended to have all the capabilities of earlier scripting languages. Perl provided many ways to state common operations and thereby allowed a programmer to adopt any convenient style. In the 1990s it became popular as a system programming tool, both for small utility programs and for prototypes of larger ones. Together with other languages discussed below, it also became popular for programming computer web servers. Document formatting languages. Document formatting languages specify the organization of printed text and graphics. They fall into several classes: text formatting notation that can serve the same functions as a word processing program, page description languages that are interpreted by a printing device, and, most generally, markup languages that describe the intended function of portions of a document. TeX. TeX was developed during 1977–86 as a text formatting language by Donald Knuth, a Stanford University professor, to improve the quality of mathematical notation in his books. Text formatting systems, unlike WYSIWYG, what you see is what you get, word processors embed plaintext formatting commands in a document, which are then interpreted by the language processor to produce a formatted document for display or printing. TeX marks italic text, for example, as \. This is italicized, which is then displayed as this is italicized. TeX largely replaced earlier text formatting languages. Its powerful and flexible abilities gave an expert precise control over such things as the choice of fonts, layout of tables, mathematical notation, and the inclusion of graphics within a document. It is generally used with the aid of macro packages that define simple commands for common operations, such as starting a new paragraph. LaTeX is a widely used package. TeX contains numerous standard style sheets for different types of documents, and these may be further adapted by each user. There are also related programs such as BibTeX, which manages bibliographies and has style sheets for all of the common bibliography styles, and versions of TeX for languages with various alphabets. PostScript. PostScript is a page description language developed in the early 1980s by Adobe Systems Incorporated on the basis of work at Xerox PARC, Palo Alto Research Center. Such languages describe documents in terms that can be interpreted by a personal computer to display the document on its screen or by a microprocessor in a printer or a typesetting device. PostScript commands can, for example, precisely position text in various fonts and sizes, draw images that are mathematically described, and specify color or shading. PostScript uses postfix, also called reverse Polish notation, in which an operation name follows its arguments. Thus, 30060020270 arcstroke means draw stroke, a 270-degree arc with radius 20 at location 300, 600. Although PostScript can be read and written by a programmer, it is normally produced by text formatting programs, word processors, or graphic display tools. The success of PostScript is due to its specifications being in the public domain and to its being a good match for high-resolution laser printers. It has influenced the development of printing fonts, and manufacturers produce a large variety of PostScript fonts. SGML. SGML, Standard Generalized Markup Language, is an international standard for the definition of markup languages, that is, it is a metalanguage. Markup consists of notations called tags that specify the function of a piece of text or how it is to be displayed. SGML emphasizes descriptive markup, in which a tag might be emphasis dot. Such a markup denotes the document function, and it could be interpreted as reverse video on a computer screen, underlining by a typewriter, or italics in typeset text.
HTML is used to specify DTDs, document type definitions.
A DTD defines a kind of document, such as a report, by specifying what elements must appear in the document, example, title, and giving rules for the use of document elements, such as that a paragraph may appear within a table entry, but a table may not appear within a paragraph.
A marked up text may be analyzed by a parsing program to determine if it conforms to a DTD. Another program may read the markups to prepare an index or to translate the document into PostScript for printing. Yet another might generate large type or audio for readers with visual or hearing disabilities.
World Wide Web display languages.
HTML. The World Wide Web is a system for displaying text, graphics, and audio retrieved over the Internet on a computer monitor.
Each retrieval unit is known as a web page, and such pages frequently contain links that allow related pages to be retrieved.
HTML, Hypertext Markup Language, is the markup language for encoding web pages.
It was designed by Tim Berners-Lee at the CERN Nuclear Physics Laboratory in Switzerland during the 1980s and is defined by an HTML DTD.
HTML markup tags specify document elements such as headings, paragraphs, and tables.
They mark up a document for display by a computer program known as a web browser. The browser interprets the tags, displaying the headings, paragraphs, and tables in a layout that is adapted to the screen size and fonts available to it.
HTML documents also contain anchors, which are tags that specify links to other web pages.
An anchor has the form ref equals http://www.britannica.com Encyclopedia Britannica/a, where the quoted string is the URL, Uniform Resource Locator, to which the link points, the web address, and the text following it is what appears in a web browser, underlined to show that it is a link to another page. What is displayed as a single page may also be formed from multiple URLs, some containing text and others graphics.